this is Professor White. Today we will talk about some special cases, primarily parallel and perpendicular lines and how to recognize them, how to draw them. Okay. Parallel lines have the same slope. Here's a parallel line. Here's another parallel. There are one set of two lines that are parallel. And if I go and look at this slope, it's rise over run and rise over run. So they are parallel, same slope. Let's say this slope is M1, this slope is M2. Numerically, they have to be the same. That's the first thing. Perpendicular lines, they are 90 degrees. This doesn't look like 90 degrees. 90 degrees is like corner of your, anything that's like that. 90 degrees. Okay? They don't look 90 degrees. They look more than 90 degrees right here because this scale is bigger than that scale. But what you need to know is if I have a slope M1 and M2, the product of their slopes, M1 times M2, has to be -1. So numerically, if I'm looking for a line perpendicular to an existing line, their slopes have to be, the product of their slopes have to be -1. Or you can think of it as the second slope is negative reciprocal of the first. Second is negative reciprocal, that means flip over, of first. So if I have a slope of 2, the second one is going to be -1 over 2. If I have a slope of -2, the second one is going to be negative reciprocal. Double negative is a positive 1 over 2. So the perpendicular lines always have opposite signs, and one is the flip version of the other one. Okay, are the lines perpendicular or parallel? This one and that one. This one is in point-slope form. Pull out the M from here. This one is also in the point-slope form. Let's put X1 here. The Y1 and X1 are a moot point. I just need to look at the slopes. So one way to check the slopes, this one is M1 and this one is M2. Is the product -1? Is -2 times 1/2 -1? Yes, it is. These are perpendicular. Let's look at that one. That one is in slope-intercept form. This one is also in slope-intercept form. Okay, this one has a slope of -3. This one has a slope of -3 as well. They are the same. Those are parallel. Oops, 2 L's. Okay, let's do another one. They are in mishmash form. Now, to be able to see that, this one is in slope-intercept form. This one has a slope of -3/2. Okay, let's put up this. This one, I really cannot tell. I have to move it around. Remember what I used to do? Pull it in slope-intercept form. Subtract 3x. You have 2y. These go. -3x plus 5. Divide everything by 2. You will get y equals -3/2 x plus 5/2. So this one has a slope of -3/2, and this one has a slope of -3/2. Guess what? These two lines are parallel. So what did I do? I just make sure that they are in the same form, and then pull out the slopes and see if their products is -1 or they are exact the same. If neither one of them happens, that means they are neither parallel nor perpendicular. All right. Now, a more difficult question might be something like this. Equation of a line that's parallel to this and that goes through -1/2. Okay, there are a couple of steps in here. I want it parallel to this. What does that mean? That means I need the slope of that first line so that I can put the second line together. So to get the slope of the first line, I'll put it in the slope-intercept form. Add x. You have 2y equals x plus 5. Now I need to isolate y. Y equals 1/2 x plus 5/2. That will give me the slope of 1/2. Now, this one says, I want the second line to go through -1, too. So I got the slope from the first line, and that means x1, y1 is simply -1, 2. What is the formula? Point slope form. Y minus y1 equals mx minus x1. Plug in. Y minus y1 is 2. M is 1/2. X minus minus, that will give me a plus. Let's draw it. It is a line that is -1, 2. That has to go through -1, 2. -1, 2. Here it is. And then it has a slope of 1/2. Start with this. Go up 1. 1/2 is 1, 2. Here's my imaginary point. Draw. That is the second line that I was looking for that has that equation. Let's double check. Remember the first one? The first one is 1/2 plus 5/2. Let's do that in dotted blue. 5/2 is 2.5. All right. So that's like 2.5. It's almost there. And then when I draw the 1/2, it's almost on top of that. Right here. Are they parallel? Absolutely. Another thing that you need to remember, if I have a line, another line on top of the same line, they are parallel. Okay. Another one. I need a line that's perpendicular to the first one. Again, I need to get the slope from the first line. -2y minus x equals 5. Add x on both sides. You'll have -2y equals x plus 5. Divide both sides by -2. You will get y equals -1/2 x, -5/2. That's my first line. Let's go to the second line. Second line needs to go through 1, -2. And it has to have a slope perpendicular to the first one. The first slope is -1/2. So that means the second slope has to be the negative reciprocal of the first. Reciprocal, flip it over. This is negative. That means it's positive. I want it to go through 1, -2 with the positive 2 slope. What's the equation? Y minus y1 equals m x minus x1. Y minus minus, that's plus. M is 2. X minus x1 is 1. That's the equation of the second line. So let's draw the second line and the first line, and let's see if they look perpendicular. This one has to go through 1, -2. Here's 1, here's 2. 1, -2 is here. And it has to have a slope of 2. Start with this, 1, 2 over 1. Here's my second line. Now let's go back to the first line. The first line had a y-intercept of -5/2, which is -2.5. 1, 2. Negative 2.5 is around here. And it has a slope of negative 1/2. That means I have to go 1 and then over 2 around here. And let's draw that. They look like they crisscross, and if I were to do this in a, this is the L1 and this one is L2. If I were to do this with skids that are matching, in other words, this way and that way is the same width, they would look like a nice 90-degree intersection. And this is the end of this section about the parallel and perpendicular lines.